Hey guys, welcome to the 2018 Level 2 Calculus exam paper walkthrough. I know this is not really relevant to many people right now, but I'm just going to keep it on my YouTube channel as for people to watch in the future, really, okay? Didn't really know what to film today, so alright. Question 1. A function f is given by f of x equals to x cubed minus 6x plus 2. Find the gradient of the graph of the function at the point where x equals to 4. Okay, so now it wants you to find the gradient. We have f of x. Okay, so now we got to find what the gradient function is. Okay, and how we're going to find the gradient function? We're going to differentiate the function to find the gradient function. Okay, and when I say differentiate, okay, we're going to say f dash of x. That's a symbol for you differentiate it once, that's one dash. If you differentiate again, that's double dash. If you differentiate again, that's dash 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 as it goes. Yeah. So f dash of x, so how are you going to differentiate, okay? So you know that x cubed is basically the same as saying 1x cubed, okay? So just the 1 ahead of the 3. So 1 of x cubed, okay? So you're going to say the 1 multiplied by the power, but then you're going to bring the power down by 1. So you can say, so you say 1x cubed, right? The 1 times the 3, that's 3. And then you take the power down by 1, okay? So the 3 becomes a 2, okay? So 1 times 3 is 3, so then the front number becomes a 3. And then we take the power down, the 3, we take it down by 1, okay? So this will become 3x squared. And it says minus 6x, right? So minus 6x, we just get rid of the x and it just becomes minus 6, okay? So the x is gone and becomes just minus 6. And then the plus 2 is just gone completely, okay? It's just gone, okay? Find the gradient of the function at the point where x equals 4. So basically now we just substitute x equals to 4 and then we can find the gradient function, okay? Not the gradient function, the gradient of the graph, okay, at x equals to 4. So we're going to say f of 4, so we're substituting 4 as x, so it equals to 3, 4 squared minus 6. And if you plug that into your calculator, that should give you f dash of 4 equals to 42. So you can say that 42 is your gradient here, okay? So 42 is your gradient. And this is an achieved question. So finding the derivative, so you differentiate the equation and you found your 42 as your gradient, you're getting achieved, okay? Not too much drama. That's going to give you an achieved here. Alright. A rectangle is expanding in area so that at all times its length is 3 times its width. Find the rate of the change of the area of the rectangle with respect to its width when the area of the rectangle is 75 centimeters cubed, okay? So it's just the length is 3 times its width, okay? So we can say the width is x centimeters long, so therefore the length is 3x centimeters long because it's 3 times the width. And you know that to find the area of a rectangle, so that equals to find the area of the rectangle, we say base times height. So then we can say that x multiplied by 3x equals to the area, okay? So then we can say 3x squared equals to the area. So right now it says find the rate of change of the area when the area is 75 centimeters squared, okay? So now we're going to find out for what is x, okay? So we're going to find what is x when the change, okay, I'm saying this wrong. So we're trying to say, we're going to try to find x, okay, at when the rectangle is 75 centimeters squared. So what is x when the area is 75 centimeters squared? And we're going to substitute this x equals to something into the gradient function to find the rate of change when the rectangle is 75 centimeters squared, okay? So first we're going to find out what is x when the rectangle is 75 centimeters squared. Then we're going to substitute this x value into the gradient function to find how it's changing, what is the rate of change at this moment in time. So like, you know the gradient of a graph, right? It's like, for example, y equals to mx plus c, right? If I say it's 3fx, okay, that means it's increasing by 3 times of x, okay? So the gradient is 3, okay? So basically, we're just going to say 3x squared equals to 75, okay? And then we can say 75 divided by 3 divided by 3 square root equals to x. And you should find that x equals to 5. So what is the rate of change when x equals to 5? So basically we're just going back to our first question now. So basically we're going to say a over x is equal to 6x. 6x, 3 times 2 is 6. 2 take the power down by 1. So it becomes 6x to the power of 1, which is the same as just 6x, okay? So a dash of x is 6x. So we can say a, substitute x equals to 5. So a dash of 5 equals to 6 times 5. And a dash of 5 equals to 30, okay? And don't forget the unit here. The unit is centimeters squared, okay, per centimeter. That's because it's changing by 30 centimeters squared. So if I increase x by 1, then the area will increase by 30 centimeters squared, okay? So if I make x equals to 6, okay, then it will increase by 30 centimeters squared. So basically that's how fast it's changing if I increase the x by 1, okay, basically. So that getting all the way here, that's going to get you a merit grade, okay? Finding the rate of change. To get it achieved, you're finding the expression for a of x. So this will get you an achieved here. Okay, moving on. The derivative of a function f is given by f dash of x equals to negative 3x plus 12x. The graph of the function has a local minimum at the point of x equals 0 and y equals to 5. So use calculus to find the value of the local maximum of the function. Okay, so basically, okay, so it has a local minimum of a point, and we're trying to find the local maximum, okay? So you see that the gradient function is negative 3x squared plus 12x, okay? So that means this is the gradient function of a function, okay? So for example, I'm gonna put this back to the f of x. So we're gonna integrate, okay? So once we integrate, we're actually gonna increase this power. So if we increase this power by 1, that becomes something. So that becomes something x cubed. And because it's something x cubed, we know that it's a cubic graph, okay? So you should know that a cubic graph looks something. Just like an example, it looks something like this. So it has like a local maximum and then a local minimum somewhere, okay? So it tells you where the local minimum is, and you're just trying to find the local maximum, okay? Because the cubic graph has 2 turning points, okay? So it's going to come here. So the graph's going to go up, and then it's going to turn direction. It's going to come back down to here. It's going to change direction again. It's going to go back up, okay? So basically, like it's like just a local max, like the turning point of the maximum and the turning point of the minimum, okay? So it tells you the graph has a local minimum at the point 0, 5, okay? Okay, so basically, you have to think about it this way. So you know when there's a turning point, right? For that brief moment, it's a straight line, so it's not changing. For just a brief moment of time, so you see a parabola here, right? For example. So for just that brief moment of time right here, there's actually no change, okay? And because it's no change, then we can say that the gradient equals to 0. Because, for example, if we say y equals to 0x plus 3, then we can know that it's not changing, so it's just going to be a straight line through 3, okay? So y will always be equal to 3, no matter what x is. For example, I substitute x equals 1000, y will still be 3, okay? So anything times 0 is still 0. And we know this because at the maximum and minimums, there's a slight moment of time where the gradient equals to 0, and there's no the rate of change is 0. And because the rate of change is 0, we can say that the gradient is equal to 0, okay? So therefore, we can substitute. We already have the gradient function. So if f dash of x is the gradient function, so therefore we can substitute 0, okay? We substitute the gradient equals to 0 to find the x values at where the where the turning points are, okay? So putting f dash of x, so putting the gradient at 0, to find where the x values, to find when the gradient is 0, okay? So it's going to be two solutions here. So 0 equals to negative 3x squared plus 12x. Okay, we're going to take the negative 3 out, okay? So we're going to say, we're going to take negative 3x out, okay? So negative 3x, that becomes x, okay? Plus and minus becomes minus 4, okay? And we can see that x either equals to 0 or negative 4, okay? Okay, so basically, okay, it tells you that the local minimum of the point is at 0, 5. So when x equals to 0, y equals to 5. So therefore, you have this x value equals to 0, okay? So here, this is the local min. And therefore, by process of elimination, we can know that this is the local max when x equals to, not negative 4, positive 4 actually. So that's the local maximum, okay? Okay, so now we have to find the, so now what we're trying to do, we're going to try to find the function for f, okay? So that means we have to integrate, okay? So how are we going to integrate this? Okay, so we're going to say f of x is equal to something, right? And it's basically the reverse of differentiation. So differentiation, you're taking the Dow, so you're multiplying the front number by the power, and then taking the power down by 1, okay? But for the integration, you're going to increase the power by 1, and then you're going to divide by the front number, okay? So basically, f of x is going to be a negative, so let's just show you how I do it. So negative 3x to power of 3, okay? So you have negative 3x to the power of 3. You took the power up by 1, and then you're going to divide the power by the front number, okay? So you have 3 divided by negative 2. You're just going to divide by 3, okay? And then we're going to say plus 12x squared, okay? So now we're going to say this number, so 12. So this is going to be, we're just going to divide this by 2 because the power is 2. We're going to divide by 2. And then we're going to have, so remember when we integrated, not integrated, remember when we differentiated back here, right? When we differentiated back here, we said that this plus 2 is gone, okay? So f dash of x, the plus 2 is gone, okay? So this could have a plus something. We don't know what that plus something is, okay? But it has like a plus something that was gone during the differentiation. So we'll just say plus c, okay? Basically, if we simplify this, we can say f of x is equal to negative x cubed plus 6x squared plus a c. We don't know what the c is, okay? So now we're going to try to find our c. Okay, so the question tells us perfectly that when x equals to 0, y equals to 5, okay? So then we can just plug x equals to 0 and y equals to 5 into this equation. So you know that 0 to the power of 3 is 0, and then x to the power of 2 is 0. 0 times anything is 0. So therefore, c has to be 5, okay? Because 6x squared is 0, and negative 3 to the power of 3 is 0, okay? 0 to the power of 3 is 0. 0 to the power of 2 times 6 is still 0, okay? So therefore, c has to be 5. So if I write it out like this, it will be 5 equals to negative 0 cubed plus 6 0 squared, and then we're going to say plus c, okay? So therefore c equals to 5, okay? So now we're still not done, okay? So it's supposed to find the local maximum of the function, okay? So now we have our full function, so we can say f of, not f dash of x, what am I doing? Okay, so f of x is equal to negative x cubed, negative x cubed plus 6x squared plus, sorry about this, oh god, plus 5, okay? So we have, this is our function. Okay, so now we found that the local maximum occurs when x equals to 4, okay? We found that here. So the local maximum occurs when x equals to 4. So simply, we're going to substitute x equals to 4 into this equation, okay? So we're going to say f of 4 equals to f of 4 equals to negative 4 to the power of 3 plus 6 4 squared plus 5. Okay, sorry, it's a bit squished. Hopefully you can still see that, okay? So 4 cubed is 64. Okay, so it becomes negative 64. Negative 64 plus 4 squared, 16. 16 times 6, that's 96. So plus 96 plus 5. And that actually gives you 37. That equals to 37. So therefore, we found the y when x equals to 4. So therefore, we can say that our local maximum is 4. So when x equals to 4, y equals to 37. That's our local maximum here. Okay? So sorry if that was a bit squished. It's quite a long question, okay? So getting all the way to finding the local maximum in this question, that's going to get you a merit grade, okay? Getting all the way to finding this, to finding the local maximum here, that's a merit grade, okay? To get the achieved grade, okay, you're finding the f of x found, so you're finding it all the way to this part here. This part here is going to get you an achieved. Or you found that f dash of x equals to 0 and x equals to 4. So either this, or it's either this right here. So it's either this, okay? That's going to get you an achieved, okay? But to get the merit, you need to find the local maximum, okay? Alright, next question. Use calculus to find the values of for x when the graph of the function f of x equals to 2 over 3 x cubed plus 9 over 2 x squared minus 5x minus 18 is increasing. So you know that when a graph is increasing, let's say a linear graph is increasing or a parabola is increasing, that means the gradient must be positive, right? So if a gradient is positive, then you can see the graph is just going up and up and up. If it has a negative gradient, then you can see it's deteriorating, so it's going down, okay? So when it's increasing, it's basically saying that the gradient is more than 0, okay? So basically, knowing from what we do, so we can just say we differentiate to find the gradient function. So we can say f dash of x, and that equals to 2 over 3 times 3, so that becomes 6 over 3. So we take the power down by 1, so 3 becomes 2, so 6 over 3x squared plus 9 over 2 times 2, that's 18 over 2. X squared, you take the power down by 1, it just becomes x. And then minus 5x, okay, we just get rid of the x, so it just becomes minus 5. And then the minus 18 is just gone, it's just rest in peace, okay? So, f dash of x equals to this, okay? So, basically, we say that that the gradient is more than 0, okay? So, therefore, we can say, we're going to simplify this. We're going to say 2x squared plus 9x minus 5 is greater than 0, okay? So now, okay, now we can factorize, okay? We can now say that 2x minus 1 and then x plus 5, and that is greater than 0, okay? So you can say when x equals to 0.5 or negative 5, then the equation equals to 0, okay? But we want it for when it's more than 0, okay? So like I said, so we have a parabola here. This is a positive parabola, so that's a positive, okay? So we can say it's parabola looking like this. So you can see when it's more than 0. So when it's more than 0, so it's more like this. Sorry, it's more like that. Sorry, let me just draw this again. This is a bad parabola. Okay, so you know, you see this is the, this is 0.5, no, negative 5 here, so negative 5 on this side, and then 0.5 on this side, okay? So you know that when it's above the x-axis, so when it's more than 0, then it's more than 0.5, so it's going this way, or it's less than negative 5, okay? So it's going this way after when it's less than negative 5, okay? So we're going to say, okay, so this only occurs when x is less than negative 5 or when x is more than 0.5. If it was between these two numbers, okay, let's say x is like, let's say x equals to not 1. Let's say x equals to -2, okay? So when, for example, -2 is going to be somewhere around here. Let's say -2 is here. And we see -2, the parabola is actually here. So then that's actually less than 0, okay? So you see it's here, it's less than 0. But if we, for example, if we have like 1, let's say 1 is here. Let's say 1 is here. So you can see here that it's actually more than 0 here, okay? So hopefully you understand that, okay? So it's either when x is less than -5 or x is more than positive 0.5, okay? So that should be your final answer. And this should get you an excellent grade if you can get all the way to this here, to this final line here. To get the merit grade, you're only finding 0.5 and -5, but you're not saying x is less than -5 and x is positive, x is more than positive 0.5. You're not saying that, and you're getting a merit for that, okay? To get achieved grade, you're finding the derivative. So you're going to find f dash of x, so that's here. And you're going to say, so you're going to say that's less than, sorry, you're going to say that's more than 0, okay? So you're going to say this is more than 0, okay? That's going to get you an achieved grade, okay? So an achieved grade for here and a merit grade for here. And the excellence grade if you can go all the way down, okay? And finish the problem, okay? Alright, next question. A rectangle ABCD is measured 8 centimeters by 10 centimeters. A parallelogram EFGH can be drawn inside the rectangle as shown in the diagram below. Suppose the distance from each corner of the rectangle to the next vertex of the parallelogram in the clockwise direction is x centimeters. That is, AE equals to BF equals to CG equals to DH equals to x, okay? Use calculus to find the smallest possible area that the parallelogram can have. Justify that this answer is a minimum, okay? So basically, if we have like a parabola, okay, let's say, just for example, of a parabola, a positive parabola. So saying when the area is minimum, okay? So that's not a good example actually. So we can say, for example, positive parabola like here. So when the area is a minimum, that will be at the lowest point here, okay? That would be the lowest point, okay? So when the area is the lowest, okay, for the x value, okay? Okay, so the first step in this question, okay, we need to find the area of the parallelogram in terms of x, okay? So you know that the rectangle is 10 times 8, so 10 times 8 equals to 80 centimeters, okay, squared, okay? And you know that the area of the parallelogram, so that's the area, just a big parallelogram here. The area of that parallelogram is equal to area of the square, area of the rectangle minus this, minus this, minus this, and minus this, okay? Alright, so you know that the area of a triangle is base times height multiplied by 0.5. That's to find the area of the triangle, okay? Half base times height. So basically you can see there's one side is labeled x centimeters for this triangle, and then the other side would be 10 centimeters, so that's all the way. So what is this side, okay? So this is this side that we don't know. Well, this side you see this is 10 centimeters here, and that's x centimeters here. So therefore we can say that this side here is 10 minus x, okay? And it's the same for this side, so this x centimeters here, and we can say this is 10 minus x, okay? And for the above, for these triangles, there's an x centimeter side, and then there's 8 centimeters here, and there's x centimeters here, so therefore this is 8 minus x, and it's the same for here, so 8 minus x, okay? So basically, okay, so we have the area of the parallelogram equals to 80 minus, because 80 is the area of the entire rectangle, so we say 80 minus 10 minus x multiplied by x. Okay, so normally we would divide by 2, okay, to find the area of that one triangle, but since we have two triangles here, so that's one here, two identical triangles, okay, just remember, these are two identical triangles, therefore we don't need to divide by 2, because if we divide by 2, we just need to times by 2 to find the two triangles, so therefore, there's really no need to, like, divide by 2, so basically, these two triangles add up to give you this, okay, so 80 minus 10 minus x times x, minus 8 minus x times x. Okay, so now we're just gonna expand this out a little bit. Okay, I'm just gonna say 80 minus, okay, so we're gonna say 80 minus 10x minus x squared minus 8x minus x squared. Okay, you're happy with that? Okay, we're just multiplying these together. Okay, so now we're gonna expand this even more, so we're gonna say 80 minus 10x, double negative makes a positive, so it becomes positive x squared. Okay, minus 8x, and then again double negative makes a positive, so we're saying plus x squared again. Okay, so now we have the area of the parallelogram, because we're going to put the like terms together. Okay, so we're going to say 2x squared minus 18x plus 80, okay, equals to area. Okay, that equals to the area. Okay, everyone's happy with that? Okay, so now we're going to find the smallest possible area the parallelogram can have. So therefore we're trying to find the turning point of the equation, so of the function. Okay, so therefore we have to differentiate to find the gradient function first. Okay, so I'm going to say a dash of x is equal to 4x. It's 4x, 2 times 2, take the power down by 1, minus 18, so the x just goes away, and then the plus 80 is just gone. Okay, so a dash of x equals to 4x minus 18, right? And you know that when for example, I'm going to draw the parabola, we're going to show the parabola again. So when the parabola is, we're trying to find the minimum, right? And you know that when, at that one moment, there's going to be, the rate of change is going to be 0. So therefore, for that one specific moment, there's going to be a gradient of 0, okay? Just for that one, like, particular moment. It's going to be like that slight moment where there's just no change happening, and therefore the gradient equals 0, okay? So basically we're trying to find that point of the graph. So therefore when we substitute the gradient equals to 0, we can find the x value at where the gradient equals to 0, okay? So we're going to say 4x minus 18, okay? And therefore x is equal to 4.5, okay? 4.5 centimeters. So basically, okay, when x equals to 4.5 centimeters, so that's this bad boy here, and this here, and this here, and this here. So when x equals to 4.5 centimeters, then the area of a parallelogram will be the smallest, okay? Okay, so basically, the smallest area for the parallelogram can be achieved when x equals to 4.5 centimeters, okay? But we're not done yet, okay? It says justify right here. It says justify that your answer is a minimum, okay? So how do we do that, okay? So basically, we're going to find f double dash of x, okay? So we're going to differentiate again, okay? So if we say f, so we're going to say a double dash of x, so a, each dash represents how many times it's been differentiated, okay? So we say a dash of x equals to 4x, 4x just becomes 4, and the minus 18 is just gone, okay? So you see that 4 is a positive number, right? So 4 is a positive number. Everyone's happy with that, okay? When it's a positive number, so when the double dash of a function is positive, then has to be a minimum, okay? But when the f double dash, or like when the function's been differentiated twice, and then it becomes a negative number represents a maximum, okay? So just remember, positive is minimum, and negative is maximum, okay? So because it's a positive, we can say that this is a minimum, okay? And yeah, that's basically it, okay? Does it say find? Oh, okay, we still need to find the smallest possible area the the parallelogram can have. That's really easy. That's just substituting 4.5 into the equation. Okay, so basically we say 4.5 squared minus 18 times 4.5 plus 80, and that should give you the answer as 39.5 centimeters squared. That should be your final answer here, right here. And you still need to prove, so this is the proof, okay? So this is justification at the bottom here. So near justify that it's a minimum, so justification is here, right, at the bottom. So a double dash of x is 4, and it's a positive, and because it's a positive, it's a minimum, okay? So if it turned out to be -4, then it will be a negative number, okay? So therefore it will be a maximum, okay? Just remember the opposite, okay? So positive, I am positively minimum. Okay, that doesn't make sense, I know, but like, just remember like the opposite of what you would usually think is the answer, okay? Getting all the way down to the bottom here, so that's the proof, and the 39.5 centimeters squared will get you an excellence, okay? To get a merit, we find the x value of the minimum, so therefore we find x equals to 4.5 centimeters. That's going to give us a merit, okay? To get the achieved grade, we're finding the area expression. So we're going to find 2x squared minus 18x plus 80 equals to the area. That's going to give us an achieved grade, okay? Okay, so that's basically it for the first question, okay? So I hope you enjoyed this video, okay? It's okay if you don't really understand anything I'm talking about in this video. It's because we haven't really learned this yet, okay? So don't worry about it, okay? Hopefully you did understand some stuff, okay? So basically, like, if you differentiate a function, you get the gradient function. And, like, the gradient function is basically, for example, if the gradient was positive, then the function would be increasing. If the gradient was a negative, then it would be decreasing. So, like, you're basically just trying to find, like, the gradient at a specific point, okay? So maybe when x equals to 4, it's currently decreasing, or when x equals to -2, it might be increasing. So like at x equals to different points, it's different, okay? So we can see this parabola here. Okay, this glitching, sorry. Just let me refresh the app. It does this sometimes. Oh. Sorry about that. Okay, so we're gonna have the parabola here. Okay, we're gonna have a parabola here, okay? Here. So at this, for example, when x maybe is equal to -2, so let's say it's -2 here, so you can see that this point is here, right? So at this point here, it's currently decreasing, as you can see. It's going down, okay? So therefore there will be a negative gradient at x equals to -2, okay? So let's say +2 then, okay? Let's say here, so you can see that x, so it's here, so -2 corresponds to here. And at this point, okay, its functions begin to increase, so therefore the gradient at this point is actually a positive gradient, okay? So basically that's what the gradient function does, okay? So by differentiating the function, we can find the gradient function, and by using the gradient function, we can find points for x at which the gradient is increasing or decreasing, or when the gradient equals to 0, so that's right at the vertex, okay? The vertex of the parabola here. Right at the vertex, the gradient is 0, and the gradient is 0 because for a slight moment, there's no rate of change. The rate of change equals to 0, and because the rate of change equals to 0, like I said, for example, if we have y equals to mx plus c, right? So we can say, for example, we say y equals to 0x plus 1, okay? So the 0 is the gradient, okay? And because it's 0x, no matter how big my x is, the y will always be equal to 1. So if I draw this out on the actual graph, okay, it's going to look something like this. So if I say this is the graph, so it's just going to look something like this. It's going to be a straight line right through 1, okay? So this point is going to be 1. So no matter how big x is, the y will always be 1 because the gradient is 0. So what I'm saying is, for a brief moment at the parabola, at the bottom of the vertex, the gradient equals to 0. So the gradient looks something like this. It's just going to be a straight line, okay, just for a brief moment, okay? After that brief moment, it's going to change direction and then go back the other way. So right, you can see here, so it's currently going down, so it's decreasing. It's going to get to the bottom, and it's going to stop for like a split second, and then it's going to go back up again. So it changes direction. That's why it's called a turning point, okay? So it's called a turning point because it changes direction. So, for example, the parabola's going down, stops for a while, it's going back up again. It changes direction, basically. And yeah, and that's really what you really need to know. So I hope you enjoyed this video, okay? Please leave a like and subscribe for more content, okay? Yeah, thanks for watching, okay? I hope to get some more videos out soon, okay? Hopefully I'm not too busy over the next couple of days, but Hope you enjoyed this video. Peace out.